In OpenCPI, there is an HDL primitive called Raw2AXI. This primitive converts HDL worker raw property interface into an AXI master. This allows the control plane to connect directly to an AXI4 slave. In this example, we will connect an AXI4-Lite register map using the Raw2AXI HDL primitive and connect that to the control plane with the control plane's raw property interface. The AXI4-Lite register map in this example was generated using AirHDL. AirHDL is an EDA tool that allows you to create register maps easily. This one in particular only has 2 registers. They're both 32 bits wide. The first one is a read-only register, which has an ID, and the second one is a scratch register that has a read-write access, so we could write to it and then read back the value to make sure that it's functioning correctly. This example can be found in the assets project, and it consists of the following artifacts. In components miscomps, there's a Raw2AXI-Lite 32 tester worker. In assets HDL assemblies, there's the assembly that instantiates that worker. And then in assets applications, you'll find an application control interface application that reads and writes those 2 registers. So this is my environment. I've already done OCPI remote load and OCPI remote start for the ADRV that I'm using. And I've also already built the application for my host, which is Ubuntu 18.04. So we just run it. It's a simple test. All it does is it reads the ID register, and then it reads the scratch register, and at reset that value is 0, and then it writes a value to that write register and then reads it back, and then you can confirm that you wrote it and it's the correct value. So the application itself, all it is that one worker, and I named it register map. And it just uses the control interface, application control interface to read that register map, those values, and write to them. Alternatively, you can use, if you SSH into the embedded device, you could use OCPI HDL to read and write those registers as well, based on the offset. So I have to do device PL0, and then V for verbose, X for hex, and then get. This will get all the workers, and you can get the index from that. And then for the Raw2AXI-Lite 32 tester, the index is 0. And then there's worker read index, and then offset. And the offset is based on the specification for that worker. Let's go there. So there's going to be an issue that handles there's a workaround to force the read and the raw properties to instantiate. I needed to add property values, standard properties from OpenCPI. So one is volatile. This will force it to be readable, and then another property that's writable. But the register map here also maps the offsets so that you can read them. So so this is 0, 4 because they're 32 bits wide, 8, and 12. So that's how you get the offsets. So we said it was 8. So this is the ID value. And then 12 is the scratch register. And you can use worker write, and you can give it a new value. and then you could read that back. So it's just another way to manipulate the registers that are running that HDL worker. So just a little rundown on the HDL worker itself. Start with the XML. The first raw property is the ID, and that refers to the spec, so the ID. So after these two, all the rest of these properties will be accessible through the raw props. And then the VHDL instantiates the HDL primitive that takes the raw properties in and out, and then it generates the master interface, AXI master and slave interfaces to interface to the register map. So in this, I have a property, a standard property called scratch readback, so that, and then the way that this register is generated, it has those values accessible, and that's where I set the ID, and that's where we get that value, 1, 2, 3, 4, 5, 6, 7. So I hope this helps if you needed to interface with a legacy worker or an existing IP core that has an AXI4-Lite control interface. And this pairs that together with the OpenCPI control interface.